Hi, everybody. We're going to do the review for the Unit 2 exam, which is coming up tomorrow. I'm going to go through a whole bunch of stuff fairly quickly. The first thing is we need to be able to work with equations of lines. And this is going to be throughout all three of the other skills. So the first thing we're going to do is find the slope every time. So before you do anything else, find the slope between 3, 2, and 6, 0. And of course, I'm going to have an ed puzzle for this, so you're going to find it on there. I am going to substitute in y2, which we're going to label this x1, y1, x2, y2. Now, you shouldn't have to do this. You all should have been doing this enough times that you could have found the slope without doing all this. But I'm going to substitute the 0 in for the y2, minus the 2 for the y1, over x2, which is 6, minus 3. And we end up with negative 2. 0 minus 2 is negative 2. 6 minus 3 is 3. And our slope is negative 2/3. This is our slope. Now, our first step for finding an equation through 2 points is always to find the slope. And so let me go to that next page. We found the slope between here, and we found that the slope was negative 2/3. And we can choose either one of these points, and we can put it in y equals mx plus b form by writing y equals mx plus b and choosing a point. Now you can choose either one of the points, it doesn't matter. I'm just going to choose the first one, and I'm going to substitute and find the b, because once you know m and b, you can write the equation. And it doesn't matter which one of these points you use. So I'm going to put in the first one. Y is 2. M is negative 2/3. X is, of course, 3 plus B. And we're almost done. The 3 divides literally into the 3, and we get negative 2 plus B is equal to 2. We add the 2 to both sides, and I'm going to add the 2. It's ridiculous, but there you go. B is by itself, and it's equal to 4. Now I'm done. All I have to do now is write the equation. Since I know that B equals 4, I can write the equation. Y equals negative 2/3 x plus 4. And that is in slope-intercept form. Now, whenever I want it in standard form, you need to multiply all the terms by 3 because we need to eliminate any fractions. So I'm going to multiply all the terms by 3. What I mean by that is y times 3, negative 2/3 x times 3, the plus 4 times 3. All I'm doing is multiplying 3 on both sides of the equation, and I'm going to simplify this. 3 simplifies out, and we get 3y equals negative 2x plus 12. All I did was multiply by 3, multiply by 3, and multiply by 3. I'm going to add 2x to both sides. I'll write it. And you get 2x plus 3y is equal to 12. This is what we call standard form. Now there's one other form, and it is so ridiculously easy if you know how to do it. And I prefer to use that all the time. Anytime I'm given a point and a slope, I always love point slope form. And here's how point slope form works. I'm going to get another point here. So one of my points, I believe, was 3, 2. And my slope was negative 2/3. And if I want point slope, all I have to do is take y minus 2 is equal to negative 2/3 x minus 3. All I did was 0 out my y and 0 out my x and put my 2/3 in. Now the formula was y minus y1 is equal to negative, that's an m, you're doing the formula, so that's an m, times x minus x1. This always works, and it's so much easier than any other method, because no matter how ugly your fraction is, no matter how bad your slope is, you can always take a point For example, -3, 5. Doesn't matter what kind of point you have, and doesn't matter what kind of slope you have. I absolutely guarantee that this is a horrible question if you were to try to do this, because your b value is going to be a fraction, and it's going to be a terrible lot of work. But if you're going to do it with point slope form, all you have to do is y minus 5. See where I got the 5? There's the y. See it? That's the y1. Equals the m, which is -2/7. And now I just have to take x minus -3. Well, we don't usually write this, but I'm going to write it for you. Minus -3, but that's really x plus 3, isn't it? So I don't usually write it, but I did it for you this time. So that is x plus 3. Now, the reason I know this is going to work is because if I put the 5 in for the y and I put the -3 in for the x, it makes this equation true. 0 equals 0, and it makes it absolutely true. So I know that -3, 5 is on my graph. I also know that my slope is -2/7 because it's in front of the x. This always works. It's a fantastic method. There are a couple more that we could go through, and I'm going to go just show this one. Now, here's your 2 points. Your homework and what you should do is find the slope, then use the y equals mx plus b to find the b. Find that b value, and you'll be able to write it. You could also, once you find the slope, write it in point slope form. And if you multiply everything through, you can write it in standard form. So that's your assignment to finish. There was another one on the review. Now, this is called an intercept, and this is called an intercept. This happens to be the x-intercept. See this x value right there? Sorry, that's an ugly x. And this happens to be a y-intercept. Well, by the way, that is b, isn't it? So if I do the slope between these, if I find the slope, which is y2 minus y1, that's -1 minus 0, over x2 minus x1, which is 0 minus 9, I get -1 over -9, which is the same as 1 over 9. Well, there's my slope, and there's my y-intercept. There's my b value right there. So I can write the equation y equals mx plus b, because I know the m and I know the b. There's the m, there's the b. And I can also write it in the other forms. Right? Let's see what else we have here. Where's my next one? There it is. Okay. So this one says, here's a standard form equation, write it in slope-intercept form. This is a very common type of problem that you have to run into. And all we have to do is find y and get it by itself. So in order to do that, you always go through the same 2 steps. If you have a standard form equation and you want to write it in slope-intercept form, all you have to do is solve for y. We subtract 6x from both sides, and we get -3y is equal to, I'm going to go ahead and switch these positions. This is really plus a -6x, so you can switch the position, -6x plus -8, or just -8, it doesn't matter. Now I can divide everything by -3. It's important that you divide all the terms by -3. And that gives you y is equal to, this -6 over -3 is really 2x. And the -8 over -3 is really positive 8/3. So this would be in slope-intercept form. In point slope form, it's a little trickier, but all you have to do to write it in point slope form is to get any point that you want. In some ways, this is kind of tricky because to get a point, you have to put a number in for x or y. The easiest point is usually 0. So I'm going to just put in 0 for x, and that gives me 8/3 for y, which isn't a great point, but it'll work. And the slope, I know, is 2. because there it is right there. And so I can write it in point slope form, which would be y minus 8/3 is equal to 2 times x minus 0, which is just 2x, which isn't very interesting because we can see that if I just subtracted 8/3, I would get the exact same thing. So anyway, that one wasn't really a good question anyway. I didn't make it. Now this one, we're going to write this in all three forms. You've got a point here and you've got a point here. If you read the points off of the graph, you would be able to do it the same way we just did. Of course, if you have a graph, you can count the slope, but it's a lot easier to just deal with the points. This happens to be -2. This point is at -2, 6, and this point is at 4, -2. And just go through all the same steps with those 2 points. You can find the slope, you can find the y-intercept, you can find all the other things. By the way, you don't even have to go through this motions of finding the y-intercept because there it is. So there you go, lots of stuff going on there. Now let's see what the next one says. Now this is skill E, functions and function notation. Really the big difference is there's a couple of things we did. First of all, instead of calling this y equals 3x minus 7, we now call it f of x equals 3x minus 7. Y is a function of x. This is -3 for x, and f of -3 is the y value that we get if we put -3 for x. So our y will be 3 times -3 minus 7. Now, they usually prefer to write this as, f of -3. This just means that I'm putting that in for x. That is -9 minus 7, which is -16. Another way to think of this is that we have a point, -3, and we're finding the y value that goes with it. Well, clearly, you need to put this -3 into your equation, which is what I did. That gives you -16, and there's your point. Let's see what else we have for functions here. Here we go. Now, a lot of times they're going to give you some points and a set of points. This is a set of points. And they want to know, is that a function or not? So long as you don't get different x's with the, as long as you don't have the same x with different y's, then you don't have a problem. In this particular case, I have 3, 5, -3, and 0 are my x's. And since all of them are different, I know for certain that this is a function. This absolutely has to be a function. The only way it would not be a function is if I had another number like 3, 6, or I had another number or another point like 5, -7, or I had another point like -3, 0, or I had another point like 0, 6. Any one of those points would have made it not a function because I would have had another x with the same value and gotten a different y value out. The mapping for this says that we take all of our x's, our 3, our 5, our -3, and our 0, and we map them into the y values. This, by the way, is called the domain, and this is called the range, all these values in there. A mapping looks like this. 3 goes to 4. 5 goes to 2. It just so happens that -3 also goes to 2. A lot of people get confused and they say, well, these two numbers are going to the same y. That's okay, as long as you know what you're getting out. That's the important part. And 0 is going to 0. So we call that thing a mapping. And we could graph it and use the vertical line test to test it. And in order to graph it, we're going to be using the graphing calculator pretty soon. So when I go to the graphing calculator, we could do these points and put them on a graph. So I'm actually going to write them down so I don't forget which ones I'm going to put on there. We're looking at 3, 4, 5, 2, negative 3, 2, and 0, 0. So if we were to look at those points, we could use the vertical line test to determine whether it's a function or not. Now, the last question is really easy because I already answered it like 4 times for you. What you want to do is come up with the x coordinate that goes right there in the blank space so that this table of values is not a function. And that's all you have to do. Now, you also want to get a y coordinate that will make it 1 to 1. So I want you to think about the x coordinate that will make it not a function. And it could have been a 1, a 2, a 6, or a 9, couldn't it? Now, the y coordinate that will make it 1 to 1 means that you can only have one y value for each x value too. It has to work both ways, in other words. So as long as you don't repeat your y's, you can have any number you want in there. So as long as it's not -2, 7, 3, or 0, any number would work. Okay? If I want to make it a function, I choose any number except 1, 2, 6, or 9. If I want to make it not a function, I choose one of these numbers, 1, 2, 6, or 9. So the actual answer to number 4 is 1, 2, 6, or 9. The answer to the number 5 is the y coordinate that will make it 1 to 1, means anything other than y is not equal to -2, 7, 3, or 0. So in a lot of ways, they're opposites of one another. The domain, of course, is the 1, 2, 6, and 9. And then, of course, we're going to choose one other number for the x's. And the range is -2, 7, 3, and 0. And of course, we would choose another y value. That's it. Domain and range. Oh, come on. There we go. Now, for sequences, we have a set of numbers and we want to look at patterns. See if you can see that if there's a pattern to these numbers. Is there something happening to them? Is it something that's happening over and over again? And in fact, they gave us a huge clue here. They said that there is a common difference. Well, remember, for a difference, you subtract. And if you subtract these two numbers, you get 7. And if you subtract these two numbers, you get 7. And if you subtract these two numbers, you get 7. What's happening is they're going up 7 every time. So the common difference is 7. One way to look at the common difference with sequences is that it's the slope. Here's the reason. You see, sequences are just a function where the x's are always 1, 2, 3, 4, 5, and so on. We call them n, but these are just your x values for a sequence, and here's your y values coming out. So the explicit formula is sort of like y equals mx plus b. The difference is that we're using an n instead. So we're talking about 7n. So a of n, that's how we write it. Instead of writing it like this, like a function, we write it with the little n down in the subscript. It's the same thing. We have a common difference or a slope of 7. Our variable is the n instead of the x. So instead of being mx, it's 7n. And we have to add the 0 term. Well, here's the problem. This number is the first term. In order to find the 0 term, you have to go 1 before. And in order to find that, you just have to go backwards 7. And you'll find your b value, if you like. And in this particular case, it is the number that came before the -3. Think about it. Since we're adding 7, in order to get backwards 1, we have to subtract 7. And that gives you -10. You could just simply write -10. Another way to write it is A sub n is 7n minus 10. So hopefully you can see that this is a lot like one of those, y equals mx plus b. Now for the really good news. This is supposedly a sequence, but it could also be described as a function where this is an x value and this is a y value. This is like f of x is equal to 40 when x is 12. Well, we know that this is the y value and this is the x value. So this one is 12, 40. And this one, of course, you can write the point. And the point, write it, is 1349. And if you have 2 points, you can find the equation through these 2 points. And it's y equals mx plus b. You can go through all the steps. Easy stuff. Find the slope, find the b value. And once you have a slope and an intercept, you can find the equation. If you substitute 1 into the equation, you can find a1. There's a lot of stuff going on, but it's not that complicated. To find the slope, we subtract. We get 49 minus 9. I'm going to do it. 49 minus 40 over 13 minus 12. So my slope is 9. My b value I can find by using either one of the points and using y equals mx plus b. I know a lot of people are going to say, well, wait a minute, this is a sequence problem. Sequence problems are really just a special case of functions, which is also a special case of equations, y equals mx plus b. So I'm going to substitute it in. I'm going to choose the first point. So I'm going to put the 40 equals, this is my point, 1240. M is 9. My x is 12 plus b. Well, I'm going to subtract 9 times 12 is 108. And when I subtract that from both sides, I get b is equal to negative 68. So my equation for these two is y equals 9x minus 68. If I want 1, I just put the 1 in there. So if I put the 1 in, I get 9 minus 68. And that's how I can find that point. Now I can write this as a of n is equal to 9n minus 68. And it's the same thing. I can also write it as an equals 9n minus 68. And it's the same thing. There is no difference. If you want a sequence, just remember your n's are 1, 2, 3, 4, 5, 6, and so on. And you're just putting the numbers in order. We're almost done. Now, we're going to do a line of best fit. And the best thing you can do is to write down your data. And I'm actually going to do this in the video. I'm actually going to write down the data. This is going to be my x's and my y's. So I have x's of 2, 9, 9, 3, 0, 5. This is not a function. And the reason it's not a function is because 9 gives me 1, but 9 also gives me 2. Right here. See this 2 points? This makes it not a function, but it is data. And I can use data, even if it violates the vertical line test, I can still put this data into my graphing calculator. And y is 9, 1, 2, 5, 10, 7. Now, I have some really, really good news for all of you. To find the best fit line, to describe the correlation, to make the scatter plot, to find the equation, and to make the prediction, you can do it all on Desmos. All the other problems that we did for this can be done on Desmos using the 2 points. Instead of putting in all these points, just put in the 2 points that they gave you, and you can do all these problems using Desmos, and it'll do it instantly for you. And I'm going to do number 1 again using Desmos, And I need to write down the points one more time. Let me get my points down. So I'm going to go back to question number 1, which was 3260. And I'm also going to do number 1 using Desmos. And I'm going to show you what I mean. So let me pause this for just a second. Well, you know what? I can go back. So I'm going to go back. This one just takes me a second. Stop share. Okay. So now what I'm going to do is I am going to go to Desmos. Now, the way you get to your Desmos calculator is you type Desmos into any search engine, and it will take you to your graphing calculator. Ta-da, there it is. Here's my graphing calculator, and I am ready to go. Now, oh, I forgot to share it. Sorry, guys. I should have shared my screen. My bad. I'll do it one more time. Hang on. Where's my screen share? There it is. Do it again. Hang on. Share. All right. I'm going to go back. I'm just going to close it. All right. I am going to go to Google Chrome for me. In any search engine, I type Desmos. And I click on it. And there's my graphing calculator. Look, see, there it is. Click. Am I not sharing again? Dang it, it did it again. It keeps doing that. This is really upsetting. Okay, I'm going to try again. There. I don't know why it does that. I think it's because I closed the window. Anyway, what I did was I went to any search engine like this. I typed Desmos. Now it's working. Okay. And I typed Desmos. I hit return. I go to Desmos. I hit my graphing calculator. Okay, there it is. Now, watch how easy this is. All I have to do is put in a table. Now, I can choose an easy table like on number 1. 3, 2, 3, 2, and 6, 0, 6, 0. And there's my graph. I can see my graph right there. Now, if I want to get the equation, I can do y1 tilde, don't forget where your tilde key is. It's that little squiggly thing. mx, don't forget the 1, plus b. Now, it just so happens that my slope is negative 0.6666667. Now, some people are going to be confused and they're going to say, well, wait a minute. How do I deal with this? Well, if I type m like this and I click on this little fraction over here, it gives me my negative 2/3, which is my slope. And here's my b value, the 4, and I can also see it on the graph. So hopefully everybody sees that in number 1, we don't have to do any of the work by hand. You can literally put your 2 points into your table. You can use the graphing calculator to graph the least squares regression line, which happens to be a perfect line of fit, and it gives you the equation, y equals mx plus b. All right, now what we're going to do is we are going to put our data in that they gave us. Now the data, I'm going to put it in a table, and it happens to be 2, 9. I'm just going to put the 9, 9. I'm putting all the x's first. 0, 5. There, I put all my x's, and I have 9, 1, 2, 5, 10, and 7. Now, I'm hoping that this looks really familiar to you because we've done this before. Now I can slide my graph over. Now, one of the questions that they ask us is, what is the correlation here? Is it going down? Is it going up? Or is there no correlation at all? Clearly, this is a negative correlation. Look, there is a line of best fit that I can even imagine that's going right through the middle. Hopefully you can see my little arrow here that's going back and forth. But there's my line of best fit. If I want to find it exactly, I use my y1 tilde mx1 plus b and look at my line of best fit. There it is. Now they also ask me to find the slope, which is negative 0.918269. And remember, if you want it as a fraction, you could do m and put it in as a fraction if you wanted, but it's pretty ugly. There's the fraction for that. My b is 9.95, almost exactly 10, isn't it? See that? So if I wanted to write my equation of this line of best fit, I could make it as accurate as I want. I could go all the way out. I could use this fraction, which would be basically almost perfect, negative 191 over 208. So it'd be y equals negative 191 over 208 x plus 9.95192, so on. There's my equation. Now they ask me for what happens at 22, I believe they ask me. So what I can do is I can just put this on my line and go to 22. Let's go down here to 22. They asked me to make a prediction. At 22, I'm going to be at negative 10.25. That's it. Done. Pretty easy. That was all the problems, I believe. And that's all you had to do. So good luck, guys. Do a little extra practice. Try going back and doing maybe a couple more of your, your equations using the Desmos, because it's really good practice. Remember, you can always add a table. I just hit the little plus key up in the corner, hit the table. I can choose any 2 points. Let me recenter this guy. I could pick points like, I don't remember one of them. I thought it was like 9, was it 90 or negative 90, something like that. I don't remember. 9, 0, and I don't know. I thought it was 0, negative 1, something like that. Anyway, remember I told you that's a y-intercept and this is an x-intercept. Anyway, the line of best fit, if I do it, is actually the line through those 2 points. y1 tilde mx1 plus b. There it is. And it hits perfectly. My slope is 1 over 9. I think my slope was negative 1/9 for the other problem. But anyway, it's very similar. I think maybe it was a negative 9 on the other one. And in this one, my b value is the 0, negative 1. There it is right there. So hopefully that helps. And I will see you back again. Bye, guys. Good luck on your test tomorrow.